recording now. You can just keep going.
I'll just keep going. Okay, cool. No worries. So kind of a look back, I got my bachelor's at UW-AOS back in 1997 and got my master's in 1999 with Michael Morgan. And he and I are still really good friends. He comes out here actually every year for the giant rib cook-off we have out here in Reno every Labor Day weekend. So it's been probably about 5 years since I've been in that very room visiting Michael. And so it's hard to believe it's been almost 20 years since I graduated. And it makes me feel really old. So what I did is when I was in Madison, I wanted to try kind of a variety of things, in terms of, okay, I really didn't know what I wanted to do with my career and my life and everything. And so I did try some TV internships, worked over at WISC with Gary Canalti for a little bit, did an internship up at KAAL TV one summer up in Austin, Minnesota, which is where Spam is made, in case you didn't know that. They actually told me to live west of the Spam factory so that you didn't get the smell where you live. Also worked at NASA JPL for a semester in Southern California. That's where I'm from. Grew up in Los Angeles near Pasadena. So go figure why I got interested in weather with fog and low clouds followed by hazy sunshine just about every afternoon. So I worked there for a little bit, kind of more research-centric, using some satellite data to look at Earth science trends. And so I was like, okay, that's cool. And both of those were cool, and I learned a lot, communication and doing research, but never really just didn't quite gel for me. And so I thought, going into the Weather Service seemed like a logical fit. I could do a bit of the communication. I could still do some research. I was really into the modeling at that point in my life, MM5 at that point, the pre-WRF. And so I got into the Weather Service as an intern in Midland, Texas. It is literally named after the fact that it's in the midpoint between El Paso and Dallas. There is almost nothing out there. The highest elevations in the city are the overpasses. But it was a great spot to start because it's super cheap. My wife, Karen, who had just graduated with her bachelor's degree in meteorology that year, we both went down there together, had no clue what we were getting into. Midlands, it's like, okay, we don't know where we're going, but it's a foot in the door. And so then went down there and was there for a year and a half, and definitely was a worthwhile experience. Learned a lot about West Texas meteorology, the dry line, all that jazz. And then got a forecaster position, a promotion to Louisville, Kentucky. Yet again, another place I had never set foot in my entire life and I never thought I would live in, but here we go. That's one of the kind of aspects of this career is sort of just taking a leap, just like, hey, what the hell, YOLO, you live life once, just let's go see what's out there. And so I went to Louisville, and that ended up being a really great place to live. I ended up getting an on-station promotion to a lead forecaster job there. It was a really nice mix of the Midwest and South, close enough to Wisconsin to come visit Karen's family. They're outside of Green Bay. And then, a lot of winter storms there, a lot of severe weather, tornadoes, and but I always had the itch to get back out west. I'm an outdoors guy, and kind of seeing the presentation, I do endurance running, trail running, and so getting back out west was kind of a priority. And so I was looking at SUP positions. When I was in the coming up through the ranks in the Weather Service, I always did science. I was doing modeling or research and papers and things like that. And that seemed like a good niche, and so I was like, okay, a SUP position, a science and operations officer position. So started bidding on those, and lots of misses. Lots of oh, you're almost there. Not quite yet. But then I got picked to come out here to Reno, and I'm like, well, yet another place I had never set foot in. I'm like, let's go see what's out there. And so came out here in 2007, and it was literally one of the hottest summers on record during the middle of a drought. That was the summer of the Angora fire in South Lake Tahoe, which Tahoe is part of our forecast area, so it's the gem of the Sierra. It's super awesome, but it also burns down periodically. And so this is one of those summers that did that, and I'm like, where the hell did we move to? I mean, it's literally on fire. There's smoke everywhere. And but fortunately, that next winter ended up being super busy. We had blizzards, and it was, oh, this is exciting, something different, and mountains and mountain meteorology, and that was, so it's a totally new experience. And that was what was fun, is we went from tornadoes and classic kind of mid-latitude cyclone meteorology in Louisville to mountain meteorology and atmospheric rivers and things like that out here in the West. So it's been fun. And so I came out here as a Sioux, and spent about 3 years doing that. And then I was like, okay, keeping it real. Kind of got bored. I was like, okay, let's see something else. And so there's actually some opportunities to go back to Washington, D.C. to do kind of a staffing position for the NOAA administrator, political appointee stuff, kind of like a staffer would be for a congressman. And so I got picked to do that. And so I went back there for a year. And I'd always thought, oh, policy, politics, I was kind of interested in that. So let's check that out. And I hated it. It was like the city was awesome to live in, but the job sucked. And so I'm like, okay. So then they ended up moving me back to the regional headquarters in Salt Lake City as kind of the head of the science division here in the Western region. And that job was also not a good fit for me. It's a lot of moving around. And then, long story short, came back here to Reno as the WCM. Position I never really thought I would do, which is kind of the outreach, the communications, the public information officer, the media person, the Skyworm person, and came back here and I love it. It's frankly the best job in the Weather Service. You get to do the science. I'm a former Sioux, so I'm still really into the science. I look at the newest tools, newest research that's out there, and I get to talk about it. I get to integrate it into briefings for public safety folks. And especially stuff on atmospheric rivers. It's we're lucky to be here where the atmospheric river concept is really taking off as a topic, and we're near UC San Diego Scripps, which is kind of where the atmospheric river Illuminati are, if you will. And so we get to talk with them and apply research to those features on the east side of the Sierra. So all in all, it's a fun job. I don't necessarily envision myself going anywhere anytime soon. We like it here. It's like a Madison-sized town, but we have casinos and we have slot machines in the grocery store. So it's maybe the main difference between Madison and here. And we have mountains, and so it's a fun place. So that's kind of just a quick little synopsis of my life after UW-AOS. Trying to think back to some of the classes I took. Some of the ones I didn't like. The one I didn't like, and I'm not going to name names, but just the topic I didn't like was radiation. Absolutely had no interest in that whatsoever. Because I had to take it twice, once undergrad and once in grad. And it was hands down my worst grades, scores, interest level. I was like, this is terrible. But once you get into the sort of the meat and potatoes classes, like the 452, 423 synoptic, mesoscale stuff, it was fun to do that. Doing Friday weather watches, being able to lead those. So I have memories of those still, remarkably, after 20 years, still remember all that stuff. So what I'm going to do is I'm going to show you some of these slides from this presentation at the Emergency Managers Conference, again, to give you a little tasty taste of some of the things we deal with out here, some of the what we call decision support that we provide public safety agencies, which is what we're getting more and more into. I think that's one of the big takeaways, is that a job in the Weather Service is becoming much less forecasting. It might even be less than 50% of your time is spent actually forecasting and looking at models and like typing up a forecast or doing grids and editing those. More of your time is actually spent interpreting that forecast for people that need to make decisions. And so it's understanding what their decision thresholds are and then applying what you know about the weather situation to those thresholds. So it's becoming much more of that. So more and more forecasters in the Weather Service are doing WCM stuff. And so it's actually, if you have an interest in a Weather Service career, having a lot of background in things like that is important. I'll have a couple comments toward the end. And so what I'll do is I'll go through this presentation, hopefully somewhat quickly, and then I'm going to just open up to whatever questions you guys have about the Weather Service, about what we do, about my experiences, and then I'll kind of talk about some, potentially like interview things, or, if you're looking for a job in the Weather Service, what are some of the things you should think about looking at. So let me get started here. I'm going to, Pete showed me how to do this earlier, so hopefully this will work. I don't promise success. What I'm going to do is I'm going to share the screen here. So stand by 1 second here. Let me show this. Okay, there's that there. So I'm going to show, let's see, I'm going to pick this screen to show, so share. So at some point here, you should be seeing my title slide, hopefully.
Not yet. Oh, there we go.
There it is. Yay. Okay, cool. So I can see just a little tiny inset of you all, and I think you can see a little tiny inset of me. So I might be looking away from the camera, but that's just because I'm looking at my slides. So hopefully we can survive this. So this is, again, a presentation I gave at the Nevada Emergency Manager Conference, just talking about our big winters that we've had, namely 2016-17. And and kind of what we learned from it. So you might jot down my email. Feel free to email me after this, really anytime if you want to talk more about weather service careers or other topics related to that. And I'm really good on email and terrible on the phone, so email's always good. And so I'll just put that offer out there. So as part of my run training, I actually do I do what I call run commutes. I actually run into work. It's about anywhere from a 7-mile to 13-mile run, depending on if I take the scenic route or not. And sometimes I do get hit in snowstorms. In fact, actually, I prefer almost running in the snow, because around here, there's a lot of people that moved to Reno that used to live in Southern California, like me, or in the Bay Area. You know, because California's getting crazy expensive, so a lot of people are moving here. Of course, that's driving up our real estate, but I guess we're already here, so we're benefiting from that. So, but when it snows, and it does snow here, people from California can't drive when the weather's dry, so they sure as hell can't drive when it's snowing. And so I actually feel safer on my trail shoes running to work than I do in my car driving into the office. So this is a story from that winter of 2016-17. It was the winter of atmospheric rivers. So I'm going to just move here to one of the bigger ones. This is precipitable water over the Pacific, and I'm going to wait till, there we go. So this is January 7, 2017. This is one of our bigger atmospheric river storms. We had, typically in a winter out here, we'll have anywhere from 5 to 10 of these atmospheric rivers make landfall, and they produce, you know, anywhere upwards of 60% of our annual precipitation in just, again, those, you know, roughly 5 or 10 storms. But the winter of 2016-17, we ended up with about 20 to 25 AR landfalls, and we had quite a few. It wasn't that much, but quite a few in this most recent winter. And so one of our forecasters, he was at the Safeway grocery store in Tahoe, and he overheard somebody. They didn't know he was a meteorologist, and they, if I hear atmospheric river one more effing time, you know, people just got sick of it. On the positive note, because the term was used so much, people actually understand it. It used to be kind of called the Pineapple Express, but you know, atmospheric river, a little bit more scientifically accurate term, and people are actually understanding what it means. It usually means it provides us a lot of our water supply, but it also can provide our big weather hazards like floods and windstorms and heavy snow events up in the Sierra. But they're also fairly predictable, so that's a really good thing. We have a lot of tools that are exciting new stuff that's developed in the last few years that can help us predict stuff 4 to 8 days out. On a positive side, one of the casinos up in Lake Tahoe actually designed a drink called the Atmospheric River, so that's all good. So, you know, we're winning there. So, you know, kind of thinking about preparation in Nevada. Again, as you might imagine, you think in Nevada, I mean, what the heck kind of extreme weather do you guys get there? Isn't it hot all the time? You know, isn't it? And it is get warm, especially down toward Las Vegas, of course. But we actually get a fair amount of significant weather. And so there's this scenario that's called ARkStorm. And I'll kind of set the stage for what this is. And this is something that actually motivates our emergency managers to get ready for significant storms. So 1997, the winter of 1997, we had multiples of these big atmospheric rivers make landfall in the Sierra. And these are images from Reno, basically underwater. That left-hand image there, that is actually the Reno International Airport underwater. So you remember those images recently from Omaha, the Air Force Base underwater? Well, this is Reno in 1997 when the Truckee River overflowed its banks, and you know, obviously air traffic was stopped. The right-hand image is the suburb of Sparks that was also underwater as a result of this river. So this is kind of the flood of modern standard here in Western Nevada. You know, that you know, people always think back to, and I have to be really careful if we're in a potential flood situation of like, don't say 1997 unless you really mean it, because people will panic over it. So that was a big flood event. Now these charts here are showing the precipitation that we saw during that big winter of 2016-17. The numbers themselves aren't necessarily too important, but one is for Tahoe, one is for Reno. The brown line is normal, the accumulated precip, and the green line is what happened. So we're looking at 250% of normal precipitation in just that winter season. Now that's a lot. So Tahoe, in excess of 60 inches of water equivalent precipitation. Reno, on the order of 14 to 15 inches, when our annual average is 7. So it was a significant winter. Again, look at all that precipitation fell just in the winter season, which again is normal around here. You know, we get most of our precip just in the winter months, and the summer is generally pretty dry. But Imagine all this precipitation, not in 90 days, but in 22 days. So that is this ARkStorm scenario is a series of really intense atmospheric rivers that all occur within about 2 to 3 weeks, and not the entire stretch of winter. So they did simulations. You remember those flood pictures from the Truckee River? So think of that is, imagine water levels 3 times that, the volume 3 times that. So we're talking about a good chunk of Reno, a city of 400,000 people, almost Madison size, being underwater. This would be a serious event. But of course, it would also affect California. And so there actually did used to be one of these. In 1862, there was actually the sort of the ARkStorm people talk about, where we had atmospheric river after atmospheric river, and it actually flooded the Central Valley of California, including the capital of Sacramento, to about 5 to 10 feet of water. The governor inaugurated, he had to actually row a boat to the state capitol to get inaugurated because everything was underwater. And so this interesting talk by Daniel Swain out of UCLA is saying that looking at climate change scenarios, kind of lumping everything together, we're actually more likely than not to see another one of these ARkStorms within the next 40 years. So that may seem like a long time, but for a planning horizon for an emergency manager, for a city that you have to get funding to build infrastructure to prepare for these events, that's really not that long of a lead time horizon. So this is one of those sort of black swan events that really just, it's super, super anomalous. But we do get these periodically, and there's been a flood history that every 100, 200 years we do get these events that come into California and Nevada. So again, this is a super extreme example, but these kind of events do hit the West Coast. So what keeps me awake professionally? These are kind of some of the intangibles that as a meteorologist in the Weather Service and as an outreach person, as a communicator in this agency, keeps me awake. One is complacency here. We live, again, in a part of the world where it's not like Wisconsin, not like the Midwest, where every few days you get some weather, and during you have severe weather season, and during the summer you get thunderstorms all the time. They know that there's enough weather that people are reminded, okay, I need to keep prepared for this. Well, out here, you might go 6 to 8 months without seeing a drop of rain or a lightning bolt or anything like that. So there's a complacency that builds. It's like, we haven't had a flood in 15 years, or we haven't had 3 feet of snow in Reno in 15 years. So why do I need to worry about it? So that's a real issue for us to face with the public. Number 2 is exposure. Reno is like Vegas and Phoenix. It's a fast-growing city, and it's growing outward into areas where we don't necessarily know what the weather threats are, downslope windstorms, flooding. A lot of the development in Reno of new homes is occurring in what frankly used to be floodplains. Of course they say they're raising it up and everything like that, but sometimes nature has a habit of taking its land back in these big floods. So that's an issue, is exposure. And the last thing is honestly, this is more societal, is selfishness, is, hey, I don't really care about this until it affects me. So that's an issue too, is when we issue a severe thunderstorm warning, which, hey, believe it or not, we do issue those out here. Even tornado warnings, we have issued tornado warnings for real tornadoes, hey, you're interrupting my judge duty program, but for a storm that's not even affecting me. Well, yeah, but it might be affecting somebody else. So there's that, it's more a societal thing. So these are kind of the intangibles that sort of we worry about. So looking back to the winter of 2016-17, it all started ahead of time with seasonal outlooks. And I have a really strong opinion on these. I'll get asked, hey, Chris, should I buy a ski pass this winter? Because a lot of ski resorts out here, they offer these super sweet deals. If you buy it ahead of time, you get a real discount. But I get these questions, and like this particular one, it's like July 22nd. Like, are you kidding me? Like, the snow from the previous winter hasn't even necessarily melted off the mountains yet. So it's like, you're asking me already? So it's like, okay, what am I supposed to do with that? So seasonal outlooks out here, yeah, they're not too good. And so here is the precipitation anomaly chart. This is a really cool thing the Western Region Climate Center does out here, where they put it into percentile rankings back to 1895. And you can see that a good chunk of California and Nevada during that big winter of 2016-17 saw record wettest amounts of rainfall. It's a huge anomaly there, all the way to Wyoming. I mean, it's a big, big winter over a large chunk of real estate. So did the CPC forecasts indicate that? Yeah. It basically said equal chances, or I start to call it equally clueless. There was no signal whatsoever. This is a half a month lead time forecast. Believe it or not, I've actually presented this, what I've exactly said, in front of CPC forecasters, and they readily admit there's definitely issues there. But so definitely a fail on that one. So it's like, if we can't forecast the biggest anomaly that we have seen in decades in terms of precipitation, even just a half a month to a month out, then what hope do we have to predict 3, 4, 5, 6 months out? And so there's actually data that shows the seasonal outlooks here in the West in particular are less reliable than, say, seasonal outlooks in other parts of the U.S. I don't necessarily know why, but our weather here is quite variable from year to year. A lot of interannual variability because, again, we depend on just such a small number of big storms to give us the bulk of our precipitation. So I like to say that you're more likely to predict what the winter is going to bring accurately months in advance. Than you're more likely to enjoy this tasty Twinkie winter sandwich than you are to predict the seasonal outlook with any accuracy. So believe it or not, I did make this once. Karen was horrified that I was doing this. It literally is a Twinkie with a hot dog and cheese whiz on top. Did I like eating it? No. And I'm sorry for those of you still eating. But it kind of gets the point across, is you're more likely to enjoy it than to produce an accurate seasonal outlook. So again, as I mentioned before, recent winters, big variability is quite normal out here in the West. So this might be a little small, but what you're going to see are those percentile graphics for each year. The top row is going to be precipitation. The bottom row is going to be temperatures. The color codes are pretty self-explanatory. So this is temperature. Generally, it's been fairly warm here, especially 2014-15, and that's when we had a super serious drought situation. That is when a good chunk of California and Nevada had huge water restrictions. And then all of a sudden in 2015-16, the moisture came back, and then, of course, 16-17, it was really busy, and then the most recent winter was more average. But this interannual variability out here is actually pretty normal, and so this makes communicating what we expect to come in the seasonal outlooks quite a challenge, because from year to year to year, there's so much swing in precipitation and even to some extent temperature. Although recently, due to climate change trends, things have warmed, which has impacted how much snow we get versus how much rain we get. So, looking more specifically at that winter of 2016, in October it started really early. We had one of those big atmospheric rivers, and initially it started with a fire and flood scenario. Believe it or not, we actually had both within 12 hours. So this is a map. Just a terrain map looking here at Reno, and you can see Lake Tahoe here down the lower left. And there's this mountain range that's between the two of them that's really steep on the east side. And so whenever you get these strong atmospheric rivers, oftentimes it's rain shadowed on the east side of this. So you get that airstream that gets dried out, and kind of the sponge gets squeezed out, and so all that's left over is the wind energy. And so you get these really intense winds right along the lee side of this mountain range, very much like Boulder, Colorado does. We get very similar winds to that. So we had an event where the vegetation was super dry, and this actually caused a prescribed burn to escape and cause a significant fire situation south of Reno. 20-plus homes were destroyed. This occurred in the middle of the night, too. This is at 2, 3 in the morning. So you can imagine this hurried evacuation. Winds are blowing at 70, 80 miles an hour, causing this fire just to roar across the valley. We got frantic phone calls from our fire partners asking, "Hey, Chris, when is this going to stop? Because this fire is just going, it's not going to stop, because the winds are going to let up." Well, what did stop it is that the nature of that atmospheric river changed such that it went from rain shadow to what we call spillover, which is where there's enough moisture to make it past the barrier of the mountains and over onto the east side of the Sierra, where we do get heavy precipitation. And so we ended up with a freshly burned area, then heavy rainfall, and then boom, we had a flash flood and a debris flow. So you can see the burnt area on that hillside there, and all the water just came running over this burnt area and flooded out into this valley. You can actually see some of the tentacles of flood water that affected some of the properties near the hillside, especially this one right here. And here's another picture of a debris flow here as well. So we do get these events, at least once or twice each winter, where we get these atmospheric rivers where they're super dry, super windy, and so there's a fire threat. Even in the middle of winter, it could be in February, we get these red flag, these fire warning days, and then they transition to heavy rainfall days, and they produce events like this. So it's definitely something we're dealing with more and more. as the climate has changed, we've gotten warmer, and so we're getting more precipitation in the form of rain, which promotes grass growth in Nevada, which is much more prone to burning. And so we've had a lot more issues with these post-fire debris flows and flash flooding. So that's actually a real opportunity for expanded knowledge into predicting these things, which often are triggered in a matter of minutes with heavy rainfall rates. So it's communicating, how do we communicate that threat to decision makers? So then we fast forward to January and February, and this is when we flooded. We had significant atmospheric rivers that affected us back to back, lots of moisture, not 1997 levels, but pretty significant amounts. And so this is a case where the atmospheric river guidance, all the model simulations, as I kind of mentioned earlier when I was kicking things off, we're becoming less forecasters and more kind of interpreters of the forecast, because in part the models are getting so good. And they're becoming reliable enough where they really, really showed that skill this winter with us, being able to predict these potential flood scenarios many days, if not weeks in advance. And so this one particular flood in early January in 2017, we actually saw in the atmospheric river landfall probabilities, we saw this thing like 10, 14 days out with a good amount of confidence. A lot of the gas ensembles were showing this, and it's like, wow. So that was a time to apply the science to communicating to our decision makers, saying, hey, in 10 days, the setup is there for a potential flood scenario in Nevada and Northern California. It's we're not, our confidence is increasing, but just a heads up, it's still super far out. Lots can change. But eventually, our confidence got high enough where we were posting social media graphics like this. Like this is not a I'll believe it when I see it forecast. It's time to act and get ready for flooding now. So nothing spins up Nevada EOCs and emergency managers like earthquakes, which thankfully in the Weather Service we don't deal with. But we do get pretty significant earthquakes out here in Nevada. Not California style, but we do get significant ones that can cause damage. The other two we are more involved in is fires and floods. Those three things are what spin a Nevada emergency manager up faster than anything. So a flood, a potential flood, it's like red alert, hands to stations. And so this is the EOC that serves Reno. And so this is our hydrologist, Tim Bardsley, and myself were stationed there in the days leading up to that January and again in February floods, providing briefings to all these decision makers, this fire departments, airports, school districts, police. The school district actually has their bus yard in a floodplain, super cheap land, I guess. And so they actually had to evacuate all their buses ahead of time, and they need upwards of 2 days notice of high confidence flooding. And so we were able to provide that, and in part due to these briefings. And so we also had flooding of these. Nevada has a lot of what we call terminal lakes, where the water doesn't go to any ocean; it just gets stuck in the Great Basin. And so we had a lake outside of Reno that developed in an area that was normally dry, and all these homes were like, "Oh, wait a minute, we didn't expect there to be water here. It's Nevada; it's a dry lake bed." So we had that issue as well. We're actually still involved with it. We're still talking to these folks, 2 years, 3 years later, because there's still a ton of water in those normally dry lake beds from this huge winter. And then this is more into February. This is not our finest hour, but this is a lesson in communication. Is we got a call from an emergency manager saying, there's a levee that's about to fail. It could flood this neighborhood. And we're like, okay, that's a classic scenario in the Weather Service where we'd issue a flash flood warning. Okay, so we did that, and we asked a few questions, and then we moved along. And we posted this to social media. Nothing gets people's attention other than bright red on a social media post, especially when it says dam break emergency. This is not a drill. And so we posted this out. I mean, it probably got the most shares and retweets of anything we've ever posted. Well, anyway, so follow-up call like an hour later. It's like, well, yeah, it's probably going to fail, but it's like a retention pond, and it's not going to really do much. And so we got tons of people spun up. I think even the governor of Nevada was interested, and it was like, oh my. So lesson learned is be really, really good about fact-checking and following up on things. Even if an emergency manager calls you, make sure that it's really what they want to communicate. So we learned that lesson the hard way there in that one. So some of the cool science we get to deal with out here in the West is measuring that rain-snow line elevation. It's not something I really had to deal with in Wisconsin or Louisville or even Midland. Something we deal with out here is the altitude of where the precipitation transitions from rain to snow. So snow level, rain, snow line, whatever. But there's this cool network in these these red triangles here called snow level radars, and they basically is a vertically pointing radar that measures the fall speed of hydrometeors as they're coming down. And the slow fall speeds here in blues and yellows are where it's snow. When it melts enough to become rain and the fall speed increases, it becomes red here with those higher speeds. And so you can easily plot up a line of what the rain snow line elevation is like. So that's a really cool tool we use. This is one of our biggest challenges, though, in the western U.S. Something that people east of the Rockies don't really deal with is what is the variability of that rain snow line? I'll be honest, model QPF, all that jazz, really good. Model snow level forecast, really bad. On a good day here, I'm feeling pretty happy. Give myself a pat on the back if my rain snow line forecasts are plus or minus 500 feet. I've had them where they've been plus or minus 2,000 feet. And it's like, ooh, that didn't work out so well. So we've had some big issues with that. So this is kind of a fun scenario looking at Reno, Lake Tahoe. So now Lake Tahoe is at 6,000 feet. Reno's at 4,500 feet. Here's the infamous Donner Pass, the Donner Party. That is at 7,200 feet there. That's where those folks got stuck in the infamous winter. And I belong to a running group called the Donner Party Mountain Runners. We have really good barbecues. And so this is a scenario, just as an example here, with a rain snow line of 5,800 feet. This is the snow forecast here. And so we're looking at, anywhere from, let's see here if I can move my, oh, there's the screen there. So is 8 to 12 at Donner Pass, nothing at Reno, and maybe 1 to 2 inches at South Lake Tahoe. Okay, that's great, and that's probably the official forecast that would go out. Now, what happens if the storm comes in a little bit warmer by just 500 feet? We're not talking. We're talking maybe a degree or two Celsius. Not a whole lot. Like pretty radical drop off in snowfall there. Donner Pass, pretty big drop off in snow. And then now let's do the opposite. Let's say it comes in colder, just 500 feet. Lower snow level, a couple degrees Celsius colder, certainly within the bounds of normal forecast error in a model simulation. So all of a sudden it's like, boom, the Stay Puft Marshmallow Man shows up. It's mass chaos on Interstate 80, which you're losing about, if that roadway is closed, you're losing about $1 to $2 million an hour in commerce that goes over Interstate 80. There's a lot of warehouses in Reno that supply materials for all the cities in Northern California because it's cheaper to operate here in Nevada. There's no one good thing about Nevada, there's no income tax, but also business taxes are pretty low here. So a lot of companies outfit here in Nevada, and then they ship goods over Donner Pass to California, including Starbucks. That's another one. Amazon has a big facility here, but the issue is that roadway can get shut down for hours, if not days. And so here's a scenario where it goes from like, okay, yeah, it might be sort of closed for a couple hours to being shut down for like a day or more, just by a 500-foot drop in that rain snow line. So that's a really critical forecast. So what we started doing in our briefings is actually showing our partners this information. It's not good enough anymore to just say, okay, it's going to snow 6 inches. It's better to say it's the most likely scenario is 6 inches, but the low end is 3 and the high end is 12. Is giving those folks those range of possibilities. So we're getting more into that probabilistic or the scenario-based approach. We've definitely sunk our teeth into that here at Reno of the scenarios, giving our partners some options so that they know, so they don't get as surprised as they could if you just gave them a single forecast. All right. So then April, May, and June, you have all that snow up in the Sierra. I mean, we're talking 200 to 300% of normal snowpack. I mean, 40, 50, 60 foot, walls of snow. I mean, it was incredible to see that amount of snow. So it's going to come down one way or the other. It melts, and frequently when we have big snows like that, we have what's called snow melt flooding. So here's some pictures from Mammoth in the Eastern Sierra. If any of you ever have a chance to take a road trip out to this part of the world, Lake Tahoe, of course, is a highlight, and justifiably so. But if you have a chance to take Highway 395 south along the Eastern Sierra and go by Mammoth Lakes, Mammoth Mountain, big ski area, do it. As far as I'm concerned, it's God's country. It is just some of the most pristine scenery you'll ever see. But they also get some big snow events, and they actually had to have the National Guard come in and truck out snow because there was so much of it in Mammoth Lakes, and they're at about 8,000 feet. They had to do it again this year. They were having real issues with the sheer amount of snow is causing structural issues for roofs. It was causing, they operated on propane tanks there. They don't have underground natural gas pipes or anything to homes. So all this weight of snow, dozens of feet of snow, was actually causing these propane tanks to shift, and then you have propane gas leaks. So we were actually providing decision support to those communities to give them heads up on potential heavy, wet snow scenarios that would add weight to the snowpack and potentially cause more impact. So so lots of snow coming down one way or the other, and so this is a neat graph. This is actually showing the amount of snow, the amount of water coming down in the red in thousands of acre feet. So if you melted off all that snow and you put it in acre feet, which is an acre large multiplied by foot depth, and versus how much reservoir storage we had to hold that water back. That is quite a radical difference there. And so we were really, really concerned, high concern for potential flooding. And we did have some in the end, but it was a lot of it's due to mitigation because they were able to dig some new channels and some new storage, plus the weather cooperated. Ended up not all coming down at once in a heat wave. It actually, we had a lot of ups and downs in the temperatures, so that helped. But there's no opportunity like a big winter like this to develop some new ways of communicating with people. And so this was the birth of the NWS Reno. This is unique to us, the NWS Reno freakout chart. This has gotten quite a following. It's basically a threat matrix that talks about the different variables, different elements that could, different calamities that could befall us. And looking out to 7 days, and I'll show you an example, it actually looks out to 2 weeks now. And it has different levels of freakoutness with you, if you will. And of course, you got to have some emoji there as well. And this is one of the few times we actually put out a purple, really bad freakout level for the snowmelt flooding. This was at the end of May into early June. Because that was a heat wave scenario. Now this ended up being not as bad because they were able to actually mitigate where some of the water went instead of causing significant flooding. But this whole winter caused the development of this chart, and people can't get enough of it. It's one of those things that took off more than I thought it would. And we actually have major public safety agencies making decisions off of something called the freakout chart. But it actually has a lot of good content in it. It's not just color-coded, but we actually can put little Twitterese, scenarios in there and talk a little bit about it. So literally somebody could just print off one chart of the briefing and read this and have a really good idea of what's coming. So that we're really proud of this. Other NWS offices do threat matrices, but I'll keep it real. They're not terribly exciting. They're more government-like, if I can say that. So we're proud of this, and I'll show you an example here in a little bit of today's, just for what it's worth. So we do get snow here in Nevada, and honestly, that is probably one of our tricky and least predictable scenarios here. Is where's that rain snow line going to be? How much snow are we going to get? Well, we also get our version of a clipper here. It's called the inside slider. And so it's a storm that comes out of the north. It's fast moving, doesn't have a lot of moisture with it, but can often produce a stripe of 1, 2, 3, 4 inches of snow. Conveniently, these always seem to hit during rush hour. I don't know why. So if we ever have a potential slider, and if it's during rush hour, well, then it's going to probably hit. The issue with these is they're not as predictable as the clippers that might hit you guys. These guys, for whatever reason, the models don't really key in on the QPF and the snowfall until you're about a day, 36 hours, maybe 48 if you're lucky, out from the event. So it's a challenge in communicating that, because it's all of a sudden we go from, oh, it looks okay Monday, to it's going to be a real, show on Monday morning. The schools are going to be messed up and things like that. So this is actually a plot from you guys, from the NWS there in Milwaukee and Sullivan, that NDOT, Nevada DOT, concurs with. They have the same data to back it up, but I like the way the chart shows that it's actually these light snow events that cause far more chaos and mayhem than the heavy snow events, just because the traffic patterns are the same. Schools aren't necessarily canceled. Life still goes on. Whereas if it's a foot of snow, it kind of shuts things down. It certainly does out here. So we see far more issues. Actually, these inside sliders are actually what we freak out about more than some of the heavy snow events. And so we had one of these back in early December of this last winter. And this is one of those days where I was hoping I would have run in, but I didn't. But I got home just in time. We had about 1 inch of snow, and it fell. And just toward the beginning of the evening commute, this is December 4th, the air temperatures dropped just below 32. So it went from just being a slushy, drivable accumulation to being a complete train wreck on the roads. The roads basically froze up with that about an inch or so of snow on the ground. So here's what happened. I did some Google screen captures here of the traffic map around Reno Sparks that afternoon. So this drive here, let's see if I can get my mouse back on here. Okay, good. Yeah, this drive here from South Reno to North Reno would normally take about 20 minutes, and it would take an hour and 40 minutes because of the traffic. So just a radical change. This, again, just an inch of snow that just happened to fall, you know, just as it fell below freezing. So these are the events. Unfortunately, they're the least predictable. So I think this is a communication challenge, is it doesn't always take a 6 to 12 to 18-inch snowstorm to cause major issues. And I know you guys have probably seen this too. Sometimes it's just those half-an-inch events that occur when it's really cold that you almost need to set the panic bells off of more than you do the 6 to 12-inch event. So there's a little sidebar here. One of our forecasters did some a little bit of research into this, is the concept of decision fatigue, and you might face this in your studies. Is you'll notice as you go through the day, and the more decisions you have to make, the less enjoyable they become, and maybe even the worse those decisions become. Like it's a hard time to make a decision at the end of the day. It's, oh God, I don't know what to eat for dinner. I'm just having that conversation with my wife. It's like, I really don't know, because I've made 500 decisions already today, even if they're relatively minor. So kind of the act of making decisions degrades one's ability to make further decisions. So we see this in the Weather Service, and you might have experienced this as well. This next image I thought was hilarious. There's Steve Jobs there. He took care of decision fatigue. He took choosing his clothes out of that realm. So it's like, okay, I'll just wear the same thing every single day that I go present. But we see this in the Weather Service. This is frequently what we do to make a forecast. And you guys probably have seen this. Is okay, I'm going to look at certain data, look at temperature, humidity, winds, pop, QPF, snow. And so you make all these decisions, but then you wait until the very end to actually make that decision. Oh, should I put a watch or warning out? What should I communicate? What should my AFD say? When there's a lot of argument, he said those last products are the most important of the day. So if anything, maybe you should be making those decisions earlier on in the day. So we've actually changed the way a lot of our forecasters have thought here. So they're actually doing a lot of the model analysis early on, and then making those decisions of watch, warning, AFD in the morning, and then doing the grid work, then doing all the detailed stuff that involves a little bit decisions here and there. So anyway, just a little bit of a sidebar there I thought might be of interest. So public messaging for snow. Again, snow is not a common thing out here. There's a lot of Californians here, so they don't know how to drive in it. So we do message snow a little bit differently out here. The brains required, that's a play on chains required out here in the West. You usually have to chain up your car if you're going up the mountains. But that image here on the right, if Interstate 80 is closed, Google will frequently tell drivers to take, oh, there's this road, Dog Valley Road, that'll take you around the closure. Well, little do they know, Dog Valley Road is basically a dirt road. It's good for running on, but it doesn't really get you anywhere. And so we've had cars just get stranded during the middle of snowstorms there. So we had to help our sheriff's department message that to get that out there. So one thing, this is kind of interesting. This might open your eyes to something a little bit different. Is when we message with the public and even our partners, is historically we've used governmentese. We've used government language, like persons shouldn't go out in weather like this. It's just very formal. But there's a lot of research out there that supports that people don't react to that. They're like, oh, okay, whatever. So we actually did some research with, of all entities, the University of Nevada English department. And now I'm not an English person. Some of my worst grades were in English. But they came up with this thing called Commonplaces. It's like, how can we communicate with the public using language that they use? And so, and kind of turning it back on them. It's like, so they data mined our social media to come up with some phrases that we could use that that people understand, that are common words, common phrases that they understand. So the official term is called Commonplaces. So these are a couple of them. This is not a I'll believe when I see it forecast, or it's going to snow down here. The phrase down here carries a lot of weight in Reno because, again, we're lower down. So it's like, oh, it snows in the mountains all the time, but when will it snow down here? So we actually use that phrase in our messaging, and we use a lot of colors and things like that. So that's proven pretty effective, but I'm sure there's more research that could be done in terms of communicating that. So this next graphic here, and I'll kind of hurry up here so we can get to any questions you guys might have. You can probably guess which phrase got us in trouble with the regional director at the Western region. Slicker than snot was not approved, but it is what it is. People really, they understood it. You know, it's a common phrase. This last one was not used as an actual graphic, but during the government shutdown, which we were affected by, I was kind of snippy, and so I put this on. We're kind of quiet, so I'm like, yep, the weather's shut down until further notice. I was really tempted to put this out, but probably would have gotten me in trouble. So, all right, so I'm going to actually, just for the sake of time here, let's see here. Yeah, we'll just keep going here. So this is actually some of where the freakout chart came from. I actually had established a wine scale and a trash can scale for storms. Basically, how much wine should I buy before the storm came up? So this is another thing that our partners actually really liked, but the people higher up in the Weather Service didn't like, and so thou shalt not do wine scales. It's funny because they've actually told us, sort of the higher ups in headquarters and stuff, they're like, they tolerate the freakout chart, but I think they understand how effective it can be, and so kind of skip over that. So of course we do briefings and webinars, as I mentioned. There's the freakout chart. That's an example of something we used where we had a red code and we actually added this week 2 outlook to it, because especially out here in the West, we can actually provide some useful guidance out to week 2. Are we going into an atmospheric river pattern? Are we going to stay dry? You know, things like that. So that's been really useful. There's those scenarios there. We do email briefings. We are Burning Man. Burning Man takes place out here, so we do actually provide briefings to the Bureau of Land Management, where we do a mini freakout chart. So they actually make tactical decisions based on that. Wind and air quality and blowing dust is often the biggest thing. Thunderstorms, when you got 60,000 people out in the middle of nowhere in the desert, they're exposed to blowing dust, they're exposed to lightning and flooding and things like that. So we do provide that kind of decision support. Of course, we can go old school. People can actually just call us if they need weather. So we pride ourselves in being available. I think that's one thing. When you come into the Weather Service, you need to be ready to talk to people about weather issues. You know, if you kind of want to just sit in front of a computer screen and not really talk to anybody, this is probably not the best place to go, especially now. Maybe 10 years ago it was, but especially now, more is expected in terms of being able to communicate with folks. We go to deployments. We have incident meteorologists. We go to EOCs. We participate in hazmat exercises. We do hazmat weather forecasts. So our forecasters actually get out with emergency managers and actually get to see what they have to deal with and learn their decision points. So I'll kind of wrap it up there, at least with the presented remarks. There's an image of our lenticular clouds. I would be willing to put our skies up with just about anybody. I think we have some of the most amazing skies out here in Nevada, especially with the lenticular clouds at sunset. I'm not sure if this will come across, but you can watch one of our weather balloon launches in 65-mile-an-hour winds here. It may or may not come across, but we'll give it a try there. There's Scott. The balloon's kind of dragging him along, and then the balloon goes up. So, all right, we'll stop with there. This is my contact. And so what I'm going to do is I'll go back to the full screen here with me. This is your chance, you know, with 10, 15 minutes, whatever you want, to basically ask me anything, you know, especially about Weather Service careers. This is a picture of me out on one of my trail runs. This is the picture of the meteorologist running toward a thunderstorm, probably on a ridgeline, probably not the wisest idea. Stated NWS careers, interviews, resumes, courses should I take? Did UW-AOS prepare me? What is my typical day, including my breakfast? I'm a big breakfast guy. So if you ask Michael Morgan about breakfast, he knows I'm professional there. So I'll end my remarks with a couple important things that I think when it comes to, you know, if I'm looking for, you know, somebody to come into the Weather Service and we're looking to hire, I'll say your attitude, and a positive attitude, far outweighs any experiences you might have. It's just, we're looking for somebody who comes in with a good attitude, a can-do attitude. It's almost even more important than the grades you had, the degrees you have. You know, just to put things in context there. If you're looking at, you know, things to set yourself apart, one thing that would really catch my eye is if you did coursework or even a minor or another degree in emergency management, GIS, communications. Those three things. would be like a game changer for my taste. So, all right. So what I'm going to do here is go back to my screen. I can see you guys. So hopefully that was at least somewhat interesting. Give you a little tasty taste of what we deal with out here. So if you all have any questions about the material that I presented or anything up, just let me know.
Questions? I have a question. So obviously there's a lot of difficulty forecasting with the orographic, like with the orography of the region. Is there anything that makes it like easier to forecast in the region, or?
Yeah, so that good question. The topography here actually it's a blessing and a curse. It's a curse in that, especially here on the east side, you know when you get an atmospheric river and the airstream goes up a mountain, it's gonna rain or snow. I mean, that's not rocket science, but on the west slopes, okay, that's easy. But what happens here on the east side is much harder. It's like how much of that moisture gets past? Are we rain shadowed? Are we spilled over? Does the moisture make it past? Do we see the high winds? So the east of these mountain areas, I think the weather forecast is a lot more challenging because those unknowns, and the models are getting better at delineating the spillover versus rain shadow and the snow level, but they're not definitely about snow level. They're not perfect yet. But like on the west sides of mountain ranges, from the windward sides, I'll say actually those mountain ranges actually make it forecasting really easy because we can identify a synoptic scale pattern that has a good predictability to it 7, 8, 9, 10 days out, and that's going to come in off the Pacific and it's going to rain or it's going to snow. I mean, it's easy. So we can start messaging that. So it's you have to know it. It makes it easier and harder.
All right, cool. Thank you.
If you don't mind me asking, how did the government shutdown impact you guys?
Oh, how did the government shut down? Yeah, we got a lot of free food. That was one thing. Everybody kind of took, after so we've been through government shutdowns before. At least in my career, I've had a handful of them, especially in the last 5 years or so, because it seems like people can't agree on anything. So, for the first week or so, it's like, okay, this is just like any other shutdown because we know we'll get paid, and okay, it'll just be a little bit late or whatever. But again, I follow politics, so I could tell this is not going to be your normal shutdown. So once it started getting to week 2, week 3, the folks here kind of got nervous, and we have a couple folks who just started, so they probably don't have a savings or anything built up, and so they got pretty nervous about their financial situation. So it definitely stressed our folks here on home life was a stressor on their job. You could definitely tell their mind wasn't totally in the game at work, and justifiably so, just because they didn't know when they were going to get paid again. So it definitely got to be an issue, and to go on, I think it ended up being 5 to 6 weeks, especially holidays. I mean, think about it. You got bills from the holidays that credit card comes due, and it's like, okay, how am I supposed to pay this? So it was a big stress. It was on a positive note. If there was a silver lining to it, I think it really gelled our partners' kind of affinity for us, because we had a lot of people come to us say, hey, we want you to know how much we appreciate what you do. And with the TV meteorologist, we had our partners, emergency managers, come by and just say, hey, they'd either bring us food or they just come by to say hi. And so I think it really built those relationships a little bit more. But I think it'll affect us long run, because I'll keep it real. There's probably a lot of folks your stage in your life that are like, do I really want to go work for the government? I mean, if they're going to shut down, again in October, potentially, it's like, okay, that doesn't sound terribly stable. So, yeah. Other questions?
Tell us about your typical breakfast. Yeah.
Oh, my typical breakfast. Oh, yeah, there you go. I was actually going to put up what's your next run. So I'll start with that for now. So I'm running a 50-miler in Auburn, which is east of Sacramento in the Sierra foothills. It's called the American River 50, and it's in early April every year. And this potentially will be the 3rd year in a row that we've had a major atmospheric river hit on that date. The models, and I can show you, but the models are really hinting at another AR event. And I'm like, are you kidding me? And so we've nicknamed it the Atmospheric River 50. So that's a new name for it. But so breakfast, I kid you not. I come in with a spread here at work. I mean, I've got avocado. I've got usually eggs. I got everything. So I eat a pretty big breakfast. I'm a big fan of that. So yeah.
Twinkies and hot dogs.
No. Yeah. No. Sometimes, I will tell you one of my favorite breakfasts, and I still do this. This is even from my pre-running days, is cold leftover pizza, and a good cup of coffee. I don't know why. It's just tasty. So.
List of champions.
Yeah.
That's true.
So what about your AOS undergrad and graduate career prepared you for what you're doing now?
So I think, looking back on it, there's definitely a few things I wish I'd done differently. And I kind of alluded to it when I finished up my remarks. Is if there were courses in like GIS, of course this is 20 years ago. GIS was like really antiquated compared to what it is today, or more courses like communications and things like that. Certainly, emergency management wasn't really a big thing back then, but that's something I probably would have done differently is maybe do some extra courses outside of the degree and more than what I did. But what I will say is AOS really prepared me in that the courses taught me how to think. And that's kind of a 30,000-foot answer, but it's the reality. Is it really taught me to think physically about the atmosphere, to think conceptually. I would not be able to come close to deriving anything right now. I couldn't derive any equation right now, but I still remember all the concepts that John and Michael and Greg and all those guys, they taught me about the physical atmosphere. So I think I really benefited from that, and that has parlayed into my work in the Weather Service because, again, as I said, I started as more of a science person, not so much an outreach person, but now as I've done more outreach, having that good science, critical thinking, understanding the physical atmosphere background really helps. It gives me credibility because I understand what's going on. So I would definitely say that would be my response to that. Nothing else? Wow. Okay. Well, thanks again for the invitation. Again, I'll peek and pass on my email if any of you are interested in following up with me. I'm happy to answer questions, interviews, if practice interview stuff, whatever. Feel free to reach out to me. And even though I'm all the way out here in Reno, I still do all that stuff. So, but thanks again.
Sounds great. Thanks, Chris. Appreciate it. Take it easy. Good luck with the run.
Yeah, I'm gonna need it.
Yeah. See you, Chris.
Okay, take care, Pete. Yep.